So today what we're going to do is take our idea from one triangle, inequalities, to two triangles, comparing one triangle here to the other one. And so if we had to say, how does this side compare to this side? We would say clearly that as the angle right here gets larger, then so does this side. It's kind of like opening your mouth wider for a bigger Dorito. You got to open the hinge of your mouth a little bit bigger. Right, yeah. Because it's all about Doritos, really. Man, you're like, that orange wall is so much more interesting right now. All right, let's take a gander here and see what we have. Today we're going to talk about something called the Hinge Theorem. We're going to talk about its converse. We're going to prove one of them and do a little dance, make a little bread, and get down tonight. All right, so the Hinge Theorem is also called the SAS Inequality Theorem, but I've only heard of it called the Hinge Theorem. So, if two sides of one triangle are congruent to two sides of another, and the included side of the first is larger than the included side of the second, then the side opposite the larger angle is larger. Oops, then that should be a than the side opposite the smaller. The side opposite the smaller. Now the funny thing about this is it's so much easier to see than it is to say. So if we look here, so what we have to see is determine that we have some congruences. Here is one side congruent to another, and here is a side congruent to side. So notice the only difference. It's this angle is opened compared to this one. So since this angle is larger right here, it's like we've opened the mouth wider to fit that bigger Dorito in right there. And this mouth is open smaller, so it's for the smaller Doritos. So in the end, the BC here is greater than the YZ there. So what are we looking for? What we have to do is just double check that we have a pair of sides congruent, and then compare the angle to see how that third side there works. Now let's continue our journey here. And now the converse is exactly true. The converse simply says that if two sides of one triangle are congruent to two sides of another, and the third side of this, the first is longer than the third side of the second, then what do you know about the angles here? That angle has to be bigger than this angle. That's all we're saying. So the converse goes from side being longer to angle being bigger. This side is longer than that, so this angle is smaller than that, or larger than that. Okay, so let's take a gander here. What we want to do is write an inequality relating the given side lengths. So which sides are smaller or larger, etc. And if there's not enough information, just say there's no conclusion at this rate. Okay, so let's see here. Notice the key is I have one side, LM, is congruent to one side there. Yay! One side here is congruent to one side there. So how does the angle, this angle, compare to this angle? Well, how does angle L compare to angle R? Well, so the angle, since the angle is smaller, clearly, why do we know that? Because 57 is smaller than 90. So what can I now say about MN because MN is opposite, compared to that one? It's less than ST. ST has to be larger. Prove this puppy and see what we have. We're going to prove the converse, which means we're going to start with side lengths and we're going to end up getting into the angles being larger. So let's see here. If we're going to go backwards, indirect proof, what's our very first? We have to actually flip that and say that A is actually less than or equal to, because that's what not equal to or not greater than means. It's either equal or less. So that means I'm going to split it up into two things. So I actually have to disprove two things to prove one thing. Yes. So the first statement that I'm going to disprove is that the measure of angle A is less than the measure of angle X. The other statement that I'm going to disprove is that the measure of angle A is equal to the measure of angle X. The equal one is actually, I think, a little bit easier. So let's attack, kill, destroy that one. So if you have two angles that were equal measures, so angle A and angle X, what do you know about the two triangles? The two triangles will be? Good. So then the triangles are congruent by side angle side. And since they're congruent by CPCTC, what has to be true? That means that BC is congruent to YZ. BC is congruent to YZ. But what do we know? What do we know right here? But they're not equal. One's greater. But this contradicts, but this contradicts the given. So what we've just proven is that's not true. Since we have a contradiction, they aren't equal. Bum, ba-dum, bum, bum. Okay, now let's go to the other one. If we have the angles being less than, so I actually have to get rid of some things up there. Okay, so if we are now told, so we're going to temporarily assume that one of the angles is larger. So let's assume, and it says that the angle, this one is larger. Undo that. Is larger than this one. So that's what we're trying to work with. So then, by the theorem we just then, by the Hinge theorem, that means that YZ has to be greater than BC. But of course, that contradicts the given as well. Coincidentally, it's contradicting the same given. It doesn't always have to contradict the same thing. But this contradicts the given. So, since this is also false, my conclusion is my assumption is wrong, and therefore, what I'm trying to prove is true. Done. So if I had a triangle that had a side length of 7 and a side length of 4, please tell your neighbor, what are your possible lengths? In other words, what's the lowest limit it could be? And what's the highest it could be? Non-inclusive. Go ahead and chat. What's the upper limit?
Less than 11.
Good. So we've got those two options. It's greater than 3 or less than 11. So we do have an upper limit and a lower limit. In the same way, if I were trying to consider what my possibilities are for angles, we also have a similar situation in the same kind of thinking here. So let's take a gander here and see, first off, what my upper limit and lower limit are going to be for the angle measures and therefore the x here. Okay, so looking at this first diagram, notice that DE is congruent to EF, and second, this is congruent to itself by reflexive property. So the only difference here is that this angle right there is somehow related to this angle right here. Now, is it bigger or smaller? Is the top angle bigger or smaller than the bottom angle, and why? But there is a lower limit too. In other words, the highest it can get, and it won't actually get there, the highest that this angle can get to is 75, but it can't be 75. So that's why we said this. But what's the lowest it could get? Let's pretend we squashed it all the way down. How big is that angle? What's the smallest it could get, theoretically? It cannot be 0. So we actually have a lower limit too, because the moment it gets to 0 and also into the negatives, we have non-angles, right? So this right here, when it lies flat against the black line segment, then we end up with no angle. So that means this has to be greater than 0, but it's got to be less than 75. Now, if you've seen these compound situations before, remember it's the same as solving an inequality, but instead of having 2 sides, you have 3 sides. So how do I get x by itself? What do I need to get rid of? Go ahead, anyone?
Negative 13.
Good, so I add the 13 to both sides. So add 13. Add 13 to both sides. And when I say both sides, I need to say all sides. So I'm adding 13 all across the board here. So now, in the end, this is 86, 7, 8, 88. I just tricked you. Oh, 88 less than x or greater than the 13. So what's my limit? X cannot be 88, so it's everything between 13 and 88. So there we go. Here's my answer. We found the lower limit and the upper limit for the value of x. In a similar way, but obviously not the same, is that we found a lower limit and an upper limit for the third side there.